Let's begin with a look at authentication and authorization. Whereas authentication is verifying a user's identity, permissions grant users or groups authorization to files and directories. Authentication is logging into a computer using credentials. Once logged in, authorization is what gives the user different levels of access. As an analogy, an employee badge with a security access code is proof as to who the individual is. The badge grants access to the door to the corporate building, thus the user has permission to enter. Share-level permissions work similarly in that users are given access to the share, or building, before they can gain access to any of the shared directories, or offices in the building. A user that has access to a directory can then access the files within the directory. Access to a folder on an Isilon cluster is determined through two sets of permissions entries, POSIX mode bits and access control list, or ACLs. The graphic shows the /dvt folder and two shares created underneath it. SMB access is dependent on both these permissions, and when the share permissions are combined with file directory permissions, the most restrictive set of permissions is enforced. For example, if a user does not have permission to the DVT share, then the user cannot write to the Linux and Win directories or files within the directories. When creating a share, two options are available: do not change existing permissions and apply Windows default ACLs. Understand the apply Windows default ACLs setting. This setting can destroy or at a minimum alter explicitly defined directory permissions that the share was created on. For example, carefully migrated permissions can be altered, creating additional work and the potential of causing data unavailability. A synthetic ACL doesn't exist on the file system and is not stored anywhere. Instead, a synthetic ACL is dynamically generated as needed, and then they are discarded. It is created in memory when a client that only understands ACLs, such as Windows clients, queries the permissions on a file, and that file only has POSIX permissions. With synthetic ACLs, POSIX mode bits are authoritative. POSIX mode bits handle permissions in Unix environments and govern the synthetic ACLs. Permissions are applied to users, groups, and everyone, and allow or deny file and directory access as needed. The read, write, and execute bits form the permissions triplets for user, group, and everyone. The mode bits can be modified using the WebUI or CLI standard Unix tools such as ChangeMod and ChangeOwn. Since POSIX govern the synthetic ACLs, changes made using ChangeMod change the synthetic ACLs. For example, running ChangeMod 775 on the /ifs dvt directory changes the mode bits to read, write, execute for a group, which changes the synthetic ACL for the group. The same behavior happens when making the access more restrictive. For example, running ChangeMod 755 changes the synthetic ACL to its corresponding permission. The ChangeMod behavior is different when ACLs are authoritative. In the example, the directory /ifs dvt win has a real ACL. The POSIX mode bits are 775. Running ChangeMod 755 makes no change to the POSIX mode bits, since merging 775 with 755 gives the combined value of 775. It is important to understand the behavior of ChangeMod. Shown is an excerpt from the Isilon Cluster WebUI page that shows the different behaviors. With synthetic ACLs, POSIX mode bits are authoritative. With that said, the most restrictive permissions will apply. The first example shows that the share permission is everyone read-only, although the POSIX indicates read, write, execute. Users will not be able to write to the share. The second example shows POSIX at 755, and although the ACL is set to a user with full control, the user cannot write to the share. POSIX is authoritative. The plus sign indicates a real or native ACL that comes directly from Windows and is applied to the file. Windows ACLs are made up of access control entries. An administrator can remove the real ACL permissions using the ChangeMod-B command. ACLs are more complex than mode bits and can express a much richer set of access rules. However, not all POSIX mode bits can be represented by Windows ACLs, any more than POSIX mode bits can represent all Windows ACLs values. Once a file has been given an ACL, the file's previous POSIX mode bits are no longer enforced. The ACL is authoritative. The first example shows a real ACL used. POSIX is set for 777 and the share permissions for the user set to read-only. Although the POSIX shows read-write-execute for everyone, the user cannot write because of the ACL. In contrast, the second example shows the case where the user can write.